We're going to talk about how we simplify access control using the .NET services. Now, John, it looks like most of you guys were here in John's talk, the one in this room right before. We're going to drill into more detail in what made John's code work, and we're going to drive home in some of the technical detail of how the .NET services, specifically the access control service, is working. My name is Justin Smith. I'm a program manager at Microsoft. I live, breathe, think consistently and every day about the access control service and security. One of the places where we're spending a lot of effort and investing heavily is how we think about this as it relates to the web. So in this presentation, I'm going to start by setting some context. So I'm going to give you an introduction to myself, a little bit of the project background, and I'll set the context for what really drove the access control service development. We'll get into the technical goo in this discussion. If you guys notice my later there, I'm trying to be hip, slick, and cool. I do want to give you a little bit of an update. The technique for the first part of this presentation, I actually first saw from a guy named Dick Hart, who now works at Microsoft. He's on the OpenID board. So a lot of the concepts that we're illustrating here are unique to the access control service, but the technique is not one that I've come up with on my own. I saw it from him in his Identity 2.0 presentation. So a little bit about me. My email address is justinsm@microsoft.com. I also have a blog. The code that we show in this session will be available on my blog. So it's blogs.msdn.com/Justin J. Smith. J stands for Joseph. Joseph is a family middle name. Fairly straightforward. Within Microsoft, I belong to 64 different groups. So the Active Directory server at Microsoft has me listed in 64 different groups. Among other things, this means I get a ton of email, right? So you have to learn how to filter email pretty quickly at Microsoft. It's a technique that you pick up in a couple of months. In addition to my Microsoft.com attributes, those 64 groups in my Microsoft.com account, I also have like at least 11 other digital identities that I use on the web. I've got at least 6 live IDs. I do quite a bit of live ID dev work, so I've got quite a few dev and test accounts, and I've got a few for myself. I've got 2 Google accounts, I've got 2 Yahoo accounts, I've got 1 Facebook account, and quite honestly, I'm not sure how many open IDs I have, but I've got quite a few. I'm assuming that this is fairly representative of your digital identity as well. You've got 11, 12, some number of digital identities. I've also got 3 email addresses that I use for my personal, family, friends communication. Justin Joseph Smith at MSN, Gmail, and Yahoo. You see the pattern there. This is how I want friends and family and important communications to happen on one of these 3 email addresses. I end up aggregating them on my own. Now, I also have 2 email accounts that I use for spam. I know I'm not alone in this, but I have 2 email accounts that I seldom, if ever, check. And they get bombarded with lots of email. And I use those email accounts when I am trying to get into a new website, right? So I have to fill out one of these infamous profile pages, right? So you're asking for my name, my first name and my last name, my email address. I have to create a password. You want me to create yet another password. And you ask me for my birth date. Even though you put optional there, I'm not going to give you my real birth date because I don't know who the hell you are. I just want to start using your site. So quite often, I will pick the oldest date. And so many sites believe that I'm 108 years old. That's fine. So the net of this, when you look at all the sites that I belong to, is I have about 286 different usernames and password combinations. Right? Now, how do I know I've got 286 of these things? Well, I use a tool called RoboForm and another tool called Skipper. Dick Hart, now a new member of Microsoft, is obviously intimately involved with Skipper. Both of these are really cool tools. They allow you to basically forget all of your passwords. They're a little bit different. They're not equivalent. But anyway, I use these to keep track of my usernames and passwords. But the net of it is that when you look at all the credentials I have to keep track of, I've got my justinsm@microsoft.com credential. I better not forget that thing, right? And we have to change our password like every couple of months, and they have to be complex passwords, and you can't change your password to what it was, last year. It's a real thing. Anyway, mine's up for renewal in like 12 days, and I get this little countdown thing. Anyway, whatever. I've got Justin SM at Microsoft.com. I've got 286 different usernames and passwords at least, and I've got 11-something identities. So I've got roughly 300 different identities. So these are different sites that want to know something about me and want to ask me to keep track of a different credential. Credential being username or password, certificate, whatever. Magic handshake, doesn't matter. Right? So I've got about 300 of these darn things. And if you had to make a movie about what this is on the web, I propose it would be something like Identity's Gone Wild. Right? It's out of control. Now, you really can look at it as a logical problem. So if you treat it like an algebra equation, let's say every person on the web has about 298 identities. When you apply this to the number of people that are on the web, I assert that you quickly get something that's radically broken. Now, not everyone feels this way, right? So you can ask yourself, is this something that actually needs to be fixed? It's kind of like trying to boil the ocean, right? This is the way it is. It has proliferated, so what are we going to do, right? Well, I assert it kind of depends on who you talk to. Some people feel this is a pain point, some people don't. I don't want to try to answer that question here. But I think one thing is absolutely true, and that is the demand to reuse existing digital identities is in ascendance. So the idea of being able to take an existing identity or set of credentials and bring it to another site that you have never worked with before is a concept that is gaining popularity. It's gaining popularity with Facebook. It's gaining popularity with Google. It is certainly gaining popularity with Live ID. And it's gaining popularity in other Microsoft areas. Anyone heard of Geneva Server? A couple people, all right? IBM is doing this. Lots of big companies are working in this arena that allow me to bring my identity to an application. So if that's the case, you could say, well, maybe this melted orb that I showed at the beginning, this thing that's broken, we just have to have this little piece of technology, and basically it's all cupcakes and bunny rabbits from there. Well, I assert there's no magic piece of technology that solves this problem, if you even want to view it as a problem. It doesn't exist. There's no bailout to fix this. Right? However, I think there's a few things that will help. Right? So when we look at it, you can look at, well, there's federation. Federation is really the concept of being able to bring an identity to an application, an existing identity. Provisioning is very important as well. If I'm a site, that site needs to have profile data about me. Synchronization, how do I keep that profile data up to date? And also authorization. All these things are really important in trying to solve what may be this strange world where each person has 300 and something different identities and credentials. Now, I'm here to talk with you about an approach to authorization. I'm not here to tell you what the right way to do authorization is. I'm here to tell you where our current thinking is at Microsoft around distributed authorization, and it certainly applies to the web. But as John indicated in his talk, a lot of this stuff also applies to the enterprises. Right? So I'm here to talk with you about a specific approach to authorization. Specifically, I'm here to talk with you about the Access Control Service. The Access Control Service is a service that's hosted by Microsoft, so it's running in our cloud, right? It's running in our data center, and it allows you as the application developer to externalize authorization policy for your application. It allows you to work with federated identities. But specifically, it allows you to say what identity, let's say John at Microsoft.com or Justin SM at Microsoft.com, what are they allowed to do in my application? That's all the Access Control Service is. It's a way to externalize authorization policy. It's also part of Microsoft's all-up identity and access control offering. When you look at Microsoft as an organization, we've got quite a few different offerings in this arena, different software and different services, and we'll drill through these in just a minute. When we look at the on-premise software, so these are things like DLLs, like developer toolkits, as well as servers, things like Geneva Server. We've got 5 basic offerings in on-premise software. On the right-hand side of the screen, we see that there's the Geneva framework. The Geneva framework is an assembly. It's a .NET assembly, and allows you to easily integrate or write your own security token service that will integrate with Active Directory, Tivoli, or any other big STS that's out there. It's purely based right now on WS Trust and WS Federation. The Live framework allows you to do the same thing for live identity, right? So we've got a couple of different developer toolkits that are on the right-hand side of the screen. In the middle, we've got this piece of software called CardSpace, and there's a new version of CardSpace coming out. It's basically an identity selector, right? It's an identity selector that allows me to do something called home realm discovery. And on the left-hand side, we've got Geneva Server and the Services Connector. These are basically ways that are mechanisms that allow you to take your corporate identity, like JustinSM@Microsoft.com, and bring that identity to other applications. That's what they're all about. And they're server offerings that are in various stages of release right now. But Geneva Server, for example, was announced at PDC. Future releases will certainly be this year. The same with Services Connector, right? So these are all technologies that we're working on at Microsoft and investing heavily. But this is all on-premise. Now, when we think about the cloud, I hope you guys like my little graphic of the cloud, a little white blob there. These are things that will run in the Microsoft data center. So we've got a few offerings. Obviously, there's Windows Live ID, so Live Identity Services. We've all got Live IDs. Does everybody in the room have a Live ID? Yeah, everybody does, right? So that's obviously running in our data center. We've also got a Federation Gateway. That's a federation provider for connecting digital identities into other applications. I'm not going to focus on the Federation Gateway yet. We've got the Access Control Service that is specifically for authorization. And we've also got this really cool thing that we'll be talking about more this year. That's running Geneva Server in Azure. So I have my on-premise Geneva Server, and I have a version of Geneva Server that will run in Azure. So the on-premise version of Geneva Server connects to Active Directory exclusively. The cloud version of Geneva Server can obviously connect to a data store, a different data store, right? So the idea is we want to have some symmetry between our on-premise and our off-premise or cloud offering there. It is specifically for federation and authorization on-premise and can also be hosted in Azure. Now, you might say, well, if Geneva Server is about doing federation and authorization, what the heck's the difference between that and the Access Control Service? Well, the big difference between ACS and Geneva Server, at least running in Azure, is ACS is all about being completely turnkey. In other words, you don't have to worry about a process running. It's just there. We worry about Microsoft. We worry about scalability. We worry about uptime. We also worry about things like geolocation, right? It's nothing that you guys have to worry about from an operations perspective. And we also, quite frankly, have a smaller subset of features. So when you look at the two options, Geneva Server running in Azure and ACS, you would be exclusively in control of Geneva Server, and you can configure it to do anything you want under the rainbow, right? That's obviously a metaphor. It's not going to be milking a cow or anything like that. And then analogous, Access Control Service, we've got a lot more constraints around uptime and scalability, so we reduce the feature set so that we can meet those requirements. That's the idea. Right? So there's a difference between the two. More will be revealed later. More will be talked about this for sure later. So you may be asking, all right, what is this Access Control Service thing? I'm just going to show you. Right? I love the sound of my own voice, but I believe that there's nothing that replaces looking at code. So let's go ahead and look at some code. As John mentioned, the Access Control Service is all about claims in, claims out, right? There's a couple different pieces to the Access Control Service. We're just going to dive right into the Access Control Service and look at how an application can use the Access Control Service. Let's think, just for a second, that I've got some attribute that I'm asserting, my application here on the screen, saying the name is Justin. What is the name? The name is something I'm making up. Just the name Justin. Could be anything you want, right? So I've got a type of that assertion, just happens to be a fancy XML namespace, and I've also got the value. That's all. I simply new that thing up, and when I run the service, or this client application, what we'll see is we'll see a token come back, and we'll also see the claims that were in that token. Now, what we're actually doing is I'm creating this claim set of Justin. And then through some client API that'll be on my blog, I simply create a self-issued SAML token. So I pass those claims into a factory method, and what comes back is a signed and encrypted security token. Has anyone worked with security tokens before in their raw form? Like 8 people. Okay, cool. Well, this is what they look like. Isn't that a lot of fun? It's a lot of fun to parse this by hand and then try to do the referencing between what encrypted the data below and where the XML or where the X509 certificate is. It's a lot of fun. The people that like to do that, I assert, are a little bit weird. I'm kind of one of them. We basically create this token, and we send it to the access control service. The access control service knows how to parse that token and extract these claims, or this claim, out of the token. It will also verify the signature of the token and do the decryption, blah, blah, blah. It'll do all that stuff. I'll show you more about that later. And so what we're doing, the first bit of code here just shows us the SAML token that's created by this call. And then when we pass that SAML token into transform for claims, we get back a token that was issued by the access control service. And so let's look at it at a real high level. Here's my self-issued token. And what I get back is a set of claims that are asserted by this token issuer, accesscontrol.windows.net/JustinDemo account. And the claim value is a role where the value is nobility. So Justin is actually a nobleman. I don't know if you knew that, but I've been declared a nobleman by many different heads of state. Actually, that's not true. But anyway, you get the idea, right? So where is this mapping done? The mapping is done in the access control service. So when I log into the access control service and I look at a particular scope, we can see that there is a rule here that says anytime you see an input claim of name where the value is Justin as asserted by the application, then return a token that contains the claim of role and the value of nobility. Does that make sense? It's claims in, claims out. That's all, right? Now, let's go ahead and create a new claim, or a new rule, as it were. And so I'm going to create a rule that says anytime you see a role of nobility as asserted by the STS, right? So I'm typing in Justin demo account. Anytime you assert this claim of nobility, then we'll issue a claim that says write law, because after all, noblemen write laws, right? So what we're doing is going from a role to a permission. Let's go back to our little application. Press F5, run the app. We're creating the self-issued SAML token. We're going to spew it out to the console. And we're also going to get back the claim set from ACS. And notice that the write law claim is there. We've passed in exactly the claim set, exactly the same claim set. We've gotten a different one back. And what we've also shown is that you can chain rules together, which is an important concept. Because remember, my initial rule was if you're Justin, you're a nobleman. And who's asserting the nobleman? The access control service. And the issuer name is this thing. Right? accesscontrol.windows.net/JustinDemo account. And the second rule is if accesscontrol.windows.net/JustinDemo account asserts nobleman, then you have a permission write law. Pretty straightforward. It's a very basic forward chaining algorithm that we're using there. Does that make sense? Pretty simple, pretty straightforward? All right, cool. Now let's go back to a demo that John did. This is a calculator demo. It's a little bit embarrassing to show this, but as soon as you add more and more capability into these demos, they get harder and harder to show how the technology is actually working. So I'm trying to keep this simple. We'll go into we'll go into how we apply this concept to the web a little bit later in the presentation. But in my service, the important point here is that my service is going to just use the incoming action, SOAP header, on the incoming message, and use that with the contract of the service to figure out the claims that are required to invoke add, subtract, multiply, divide. Right? Very straightforward. This is code that I'll have on my blog. This simply makes it really easy. Makes it really easy to set up claims requirements in your application. So in this action authorization manager, basically we get a pointer to the service contract, and then we say that the claim values that are required are the concatenation of the contract name plus the operation. So it's contract name dot operation, right? And then from the incoming request, I go extract the claims that have been pushed into the WCF pipeline using the operation context dot service security context type, right? Once I've got those claims, I need to verify that the access control service is indeed the issuer, right? So I just do some link there. And what I'm doing is making sure that the SAML issuer name is the authorized issuer, which happens to be just the demo account. If they are not asserted by that, then we return false, meaning you're not authorized. Then we go get all the action claims that are in the requester. We do a basic intersection operation, and we return true if the right action claim is present. It's just like 20 lines of link. It's not that bad. And you could argue that you can even trim it down further. But that's basically all you have to do to get this calculator service to run, where automatically in the implementation of the calculator service, you require claims to invoke add, subtract, multiply, divide. Notice there's not one line of code in there that says you must have this claim. That's all done previously, and it's further down in the pipeline using this authorization manager. That's the trick. So now let's look at the client. And the client is using code that, again, I'll have on my blog. It's a new proxy, if you will. This token client type that's up there at the top is simply a way to remove all of the complexities around the protocol. Because really what you're trying to do, if you're a client application communicating with a service, you just want to talk to it. You don't really give a darn what the encrypting keys are. You don't really care if it's a REST-based protocol or if it's some other fancier protocol. You really don't care, right? And I say WS Trust is fancier. I believe they're roughly similar. That's how long I've been looking at this stuff. But anyway, all you want to be able to do is talk to the darn service. And so really what we're doing is creating a new token client. We pass in some claims. And what I get back is a security token. I'll then send that security token to the calculator service, right? Now let's look at our configuration on the access control service. And when I look at the scope for localhost calculator service, I see that there's only one rule, and that means Justin at Calc Demo has calculator add. Now multiplication is kind of a function of addition, so we should actually be able to do multiply if we can do add, right? If I can add 2 plus 2, why can't I multiply 2 times 2? Pretty straightforward. So in my code, we'll actually add and we'll multiply. I'm going to go ahead and start these things up. And once the calculator service starts to listen, we'll run the client. So I'm going to press enter to start. And we're actually going to end up with an error. So there's the error. And notice what's been thrown is an access is denied exception. Why is access denied? Because I can only add in access control. I can't multiply. Seems kind of silly, again, because adding and multiplying are sort of cousins. So let's say that I add a rule that says anytime I'm granted the calculator.add permission, or action claim, as it were, also issue the calculator.multiply claim. So we're just chaining these two together. So now as outputs, I've got add and multiply. Let's run this one more time. Here's the service. Here's my client. Hot dog, it works. So the rule chaining is the thing I'm trying to get across here. Right? You can simply chain rules together and you get different claim sets out. Any questions, comments, or personal attacks so far? One, yes. Okay.
Can you create, I know with Geneva, one of the big things you can create is custom claim types. Is that a restriction with respect to ACS? Can you create custom types?
So the question is, can you create custom claim types in Access Control Service? Well, I'm glad you asked that question, because you can. You can go to the claim types entry there and add a new claim type. Foobar, and there's your claim type. And now, when you go create a new rule, the new claim type will show up here. Right? So what we're doing is building a flexible security token service. Right? And right now, the security token service speaks WS Trust and WS Fed. We're going to make it speak REST. Right? We've gotten a heck of a lot of traction internally on how that will move forward. It's something we're absolutely committed to. This will be able to speak other protocols. Right? But for right now, I view the protocols as basically the same thing. They follow the same pattern. Okay? So, good question. Any other questions? Yes?
Is there an API or web service around setting these up? Because like something like tying a username to a role you wouldn't want to do one by one through this.
That's a great question. So the question is, do you have an API for doing what we're doing on the portal? For basically setting up a new claim type, adding a new rule, modifying an existing rule, et cetera, right? Yes, we do. And that API right now ships in our SDK. So we have a little client piece of code that allows you to do this programmatically. In the future, we've got an Atom Hub version of the rule set, the rule API, that we're actually closing out right now. Like it's code complete. We're going through testing right now. So the API for interacting with this is going to be Atom Pub. Any other questions? Now, what strikes you like something really, like there's a big shift you can make here mentally, and like I started to get real fired up about it. What's our initial premise, right, in the beginning of this talk? It's like I've got how many different identities? I've got like 300 different sets of usernames and passwords. I've got 6 Live ID accounts. I've got 2 Google accounts. I've got 200 and something different usernames and passwords. Where's the username in this thing, in this sample? Where's the username and password? Where is the raw credential? It doesn't exist. It doesn't exist in the format that's very popular today. What we're doing is using token signatures to vouch for the authenticity of what's in the token. That's all. And it gives you the complete freedom to change this to whatever you want. It's a very different model from just managing usernames and passwords. It gives you a much richer set of capabilities, right? And so I assert that this is an important switch to make. Notice also that here we're creating one of these self-issued tokens, right? We're creating a self-issued token and sending it to ACS. If we want to integrate with an Active Directory service or a Tivoli service, like you want to integrate with Toyota that uses Tivoli, the jump between this little Mickey Mouse sample and doing that is just a little hop, because it's still going to be a token. And that token you transmit to the relying party in ACS exactly the same way. Exactly the same way. Anyway, I get excited in case you can't tell. So there's the demo. There's an archetype. There's a basic pattern here. This pattern applies to ACS. It applies to every security technology I know that's worth its salt, including the ones that are on the web, et cetera. Right? This model is basically the same approach. So let's say we have a user. Let's say we have an application. Application's on the left, user's on the right, and up in the middle we've got the access control project because it makes a pretty triangle if we place these things that way. At the beginning, the application, the relying party, will establish trust with the access control service. This could be done through a key or a certificate exchange. Basically, send them your public key. At that point, some outside force will come in and create access control rules in the access control service. This could be done programmatically or through the web API. At that point, the user is going to send a token to the access control service. This is going to contain claims like identity. This could be an open ID, could be a Yahoo ID, could be a Facebook identifier. There's all kinds of things that you can put in this token. It's completely arbitrary. You just saw me put some crazy name in there. You put anything you want in there. The access control service will then run its rule engine, its magical rule engine, and come up with a set of claims that it will wrap in a token and send back to the requester. The requester will then forward that token on to the relying party with whatever payload it sees fit. At that point, the relying party has to check the token, the authenticity of the token, and also verify the claims that are in the token. Real simple. This is the archetypal pattern that is the theoretical right way to do security. Right? This shows up in lots of different protocols today. You can look at OAuth, and it's kind of similar to this. You look at OpenID. It's got a lot of these same characteristics. You look at WS Trust and WS Federation. It's very similar to this. Right? It's the same model. Let's talk a little bit about signing and encrypting. So I hunted around on the web to find the right key. We'll see how this works. So our user is going to have a private key. It's the orange key down there at the bottom. If it's got its private key, it of course also has its public key. So the requester, when it wants to send a token to the access control service, it basically has to give the access control service its public key. Notice there's an orange key that's registered up at the top left with the access control service. Why? Because the access control service has to be able to validate the token that it's receiving. Right? So if the requester sends a token to the access control service, that token is going to be signed with its private key, the orange key down at the bottom, and it's going to be encrypted with the key that the access control service is using. Right? So it's signed with a cert that the user understands, it's got the private key for, and it encrypts with the public key cert of the access control service project. Pretty straightforward, right? Does this make sense to everybody? All right? The token that comes back, because remember, this token is going to be sent to the requester, is going to be signed by the access control service. So it's going to be signed with the private key that the access control service is using, and it's encrypted with the public key of the user. So when the token is then sent to the requester can use its private key to verify or to decrypt the token, and it can use the public key of the access control service to verify authenticity. Right? Now, these can be things like RSA signatures. We can have public-private keys, but you can also do this in symmetric keys. So you can do this using 128-bit symmetric keys or whatever strength key you want. Right? The approach is very similar. It just so happens in this model, what I'm showing today, we're using public-private key pairs. But everything that you can do with public-private key pairs, you can do with symmetric keys. Make sense? And when you look at how like Facebook requires registration, right? They give you a key. They give you a number. Same thing with Amazon. When you register with them, they give you a number. They give you a key, right? And these things are all used in roughly the same way. There's obviously slight differences, those kinds of things. You can't just do a cookie-cutter approach. But the model is exactly the same. I over-exaggerate this thing, but access control service does exactly one thing. Claims in, claims out, all the live long day, hoo-ha, hoo-ha. That's what we do. We take claims in, we transform them into claims out. It's a wonderful life that we do lead because we know exactly what our mission is. We do claims in to claims out. That's all the access control service does. Let me say it another way with a picture. We have a rules engine where we can chain claims together. So rules or claims come in. Notice my little graphic with the cogs that are chained together. We then get some claims out, and you get to configure the placement of these cogs. Make sense? So here's an emblematic rule. Let's say Microsoft.com, domain users in Microsoft.com are going to be transformed into foo app users. You guys have seen how to do this on the, in several demonstrations now. So claims in are transformed into claims out. You could take another approach. Foo app users, some arbitrary claim type. Claims in are going to be transformed into foo app reads. We're going to go from a role to a permission. That's important in RBAC style processing. Now, out of curiosity, who in here, the applications that they write, who in here uses roles, application roles? Raise your hand. I'm seeing just about every single hand in the room go up. This is a way that you can do roles using a hosted cloud service. So really, when you send a claim into this engine, Microsoft domain users, what you get out is a foo app user role, and you also get the permission of foo app read. Real simple, real straightforward, claims in, claims out, all the live long day. Hoo-ha, hoo-ha. Next slide's a little bit interesting. ACS can work with any identity. You saw me have ACS work with some arbitrary name, right? Just Justin. The access control service can work with any identity provider that you can envision and then some. It can work with any identity provider that I can envision. John showed you some of this potential earlier. I mean, we were working with Facebook, in Google App Engine, and OpenID that gives us the mechanism to get to Yahoo and Google IDs, and also live IDs. Right? So the access control service can work with literally any identity under the sun. Which really means, if we tie it back to our original assertion, that the access control service can work with any of these different identities. So the access control service, rather than trying to boil the ocean and tell you you must use one type of identity and exactly one type of identity, all their identities are false identities, and you will renounce any acceptance of those identities. What we're doing here is saying, we'll let you work with anything you want. We're trying to be open and flexible. We're going to continue to be open and flexible. We're bendy, right? We're trying to conform to the way most people interact with the web, right? I assert that most people have lots of different digital identities. And a challenge that you face today, if you're building an internet-facing website or you're building as an ISV lots of different enterprises that are your customers, is how do I come up with a model for authorization that accepts all these different kinds of identities and doesn't force them into incrementing this number by one, right? So that's what we're doing here. This is the thing I've been thinking about for a while now, and I assume that I'll continue to be thinking about it going forward. Let's show ACS and OpenID. Before I show access control service and OpenID, does anybody have any questions, comments, or personal attacks as we move forward? None? I'm doing that good of a job. Awesome. I'd love to hear that. All right. So I've gone out and downloaded a little app called .NET OpenID. It's a little library, right? It's a little library that's out on Google Code, right? Scott Hanselman helped write this. There's 4 or 5 people that helped write it. And it's basically a series of assemblies and ASP.NET controls that allow you to build both an OpenID provider and an OpenID consumer. Make sense? Who in here has a site that's an OpenID consumer? 0. 1. Awesome. All right? Who in here has a service or a site that's an OpenID provider? Okay. All right. Well, none. Here's how you build a relying party. So this allows you to build a site or a service that allows people to walk up to it with an existing OpenID, a Google identity or a Yahoo identity. right? And this is using code that I've literally just downloaded off of the Google Code site. So in my relying party app, I'm going to try to access a restricted area. And it starts to prompt me for my OpenID. And so I'm going to say that I'm Bob. Now, this OpenID login is using the OpenID provider that shipped with .NET OpenID. Right? I'm not, because of demo restrictions, et cetera, I'm not going out and talking to some other OpenID provider, although I could just as easily. So I'm going to go ahead and log in. Let me make sure I've got the right OpenID URL. Make it a lot easier. Try it one more time. All right. So now I've got the right OpenID provider. Now the OpenID provider that I've been redirected to is prompting me for my password. Well, the password is test. Now I'm going to log in. Now OpenID has a mechanism for managing profile data as well. So I'm still at the provider page. So I'm still at the identity provider page. And the identity provider is saying, well, how much information do you want me to release to the relying party? Well, I'm going to say that I'm a male, last I checked, and the time zone, because it's too hard to find the US in there, we're just going to say we're in London. Okay? And I'm going to say yes. Now what we're going to be sent back to the relying party application, and this profile information is going to be available. But notice, my nobleman status has followed me even to the, I can't get away from being a nobleman. Because in the output, notice the access control service has indicated that Bob at that OpenID is a nobleman. Right? And down here at the bottom, we've got profile information. So where's the pivot here? The pivot here is that the owner of the identity, the male that lives in 98052 and the time zone is in London, is in control of that information, that profile information being released. We're giving end users the ability to control their own profile information. But up at the top, the application, the relying party, this page that we're looking at, has the ability to map that identity into some arbitrary role. And that mapping is in the exclusive control of this OpenID provider. Because that indicates what that user is allowed to do. It's not who the user is or any attributes about the user, it's really what are they allowed to do. You can get into semantic differences about what's the difference between those two, but I think you get the idea. So I assert that this is the right way to do identity and access control. Put the users in charge of their own identities. Apps control what an end user can do. Right? Now, how does this code actually work? How did I write this code? Because remember, I'm starting with code that I got off of Google Code. Well, in my relying party web app, I went to the login page, and this is the standard login code that was on the on Google Code, and I added this. It looks very similar. That's the code that I added. Now, let's look at what this code is actually doing. Remember what we're doing with this token client. This token client's going to create a token. It's going to create a self-issued SAML token. And what is it adding to that SAML token? It's adding a custom claim that says the friendly login name is an OpenID claim. I'm going to package this claim up into a token. That token is going to be signed. Oops. It's going to be signed with this cert. Right? And I've got the private key for that certificate. We're going to send that token to the access control service. Specifically, we're going to deliver that token to a particular scope. And the scope is going to have this URI. And because we want to decrypt the token that's going to come back from the access control service, I need to also specify the encrypting certificate that the access control service is going to use. So when the token comes back from access control, I just shred the token and get the claims back. Right? So I'm doing this a little bit fast and loose, but you can see that I'm just pointing to the two certificates that are used. Relying party, oh gosh darn it, sorry. Relying party web form signing and relying party web forms encrypting. Now, how are these things configured in the access control service? When we go to our scope, and we look at encryption, we can specify the certificate that ACS is going to use to encrypt tokens. And if we go ahead and look at the certificate that I've got there, it is indeed the relying party web form signing certificate, or I'm sorry, encrypting certificate, right? Now when we look at setting up the trust or the ability to accept a token that we issue, I'd create a token issuer, and I can look at the cert that we're using for shredding incoming tokens, and it's relying party web form signing, right? But notice there's no private key here. We're not asking access control to do private key management, right? It's simply managing public keys. Private keys are elsewhere. Obviously, the access control service has its own private key, but we use one key for signing tokens outbound, right? Okay. Does this make sense? The model makes sense? This is the thing, this token client, and this approach to managing claims in and claims out is what allowed John to layer all that stuff on top of this basic model to where we're doing things like dinner menu management. We're running inside of Google App Engine because there's another service that's managing cookies, right? All this stuff is done using this same basic premise. Pretty simple, pretty straightforward, claims in, claims out, all the live long day. Hooray. So what we've just done is connected our rules engine in such a way that you can send in an OpenID friendly name, and what you get back is a role and a permission. So substitute any identity provider you want here, Facebook, Live, anything you want, it will work with this rules engine. Here's the basic swim lane diagram. Right? And I've simplified this. I'm not showing all the redirects. I'm not showing all the OpenID interactions. But basically, you have a browser, and you try to log into the site. Right? And so there's some interactions that are going in this first arrow. Right? But eventually, an OpenID ticket is going to be received by the website. Right? The website's going to receive the OpenID ticket. It's going to have to validate it. It takes the content of that OpenID ticket, packages it up into a token, sends it to the access control service. The access control service then runs rules and spits back a different token that happened to have role claims in it, right? From that point, the website can take that value, the values of those claims, write it in a cookie and return the resource. It's exactly what John showed today. Basically this exact approach. And so when you look at this model from John's talk, the thing that's doing the cookie writing is acs.chefsinternational.com. Right? And so really what he's saying is there's a service that's running on top of the access control service that is making this simply a cookie management exercise. Right? So it's a matter of indirection there. And as he said, at Microsoft, we're looking at different ways of making that even easier to do, making it even easier to have an acs.chefsinternational.com. Make sense? All right, cool. So hopefully now you can see some of the different ways that the access control service will allow you to do these 5 kind of cool things. right? One is, how do I build a web page where I share that web page only to some people that I trust because of my interactions with them on World of Warcraft, right? So I want to be able to do that in just a little bit of code. And using the code that John showed, coupled with the code that I've showed, you see how this is even possible, independent of any of the identities that are there. Is it going to be Facebook? Is it going to be Google? Is it going to be anything? You can also see how you can do something more sophisticated, like let's say I want to own a chunk of advertising space in a virtual game, right? So I want to own advertising space in Halo or a driving game. I want to control that signage, start our own arbitrage system for managing real estate and values of ad properties inside of games. It's not that far off, right? But the management of the transactions around that piece of property can be driven purely out of the access control service. Another one, how do we give enterprise users access to a training application that happens to be written in Python? It's the exact same approach, right? Because the leap between doing these little tokens that we're building through the token client and a token that comes from Tivoli or Geneva is trivial. It's the same thing. Because we've got a system of rules and because we've got a chaining engine inside the access control service, it becomes simple to create reports that basically say this identity, this user, this input claim has access to these 25 different things. That's quite a powerful solution when you think about where bigger, as an organization gets bigger and bigger, this becomes more and more important to have that kind of capability. And we're extending this going forward. You can also, say, hey, I want my friends to have access to my party pictures, but I don't want to have them broad in general. And I don't want to ask my friends to create a new identity. Bring your existing identity to the party, please. So the Cliff's Notes version of this entire talk, you can boil down to 3 points, right? And I like to keep things really simple. Some say it's because I have a simple mind. But access control service is turnkey. It's about scalability. It's about uptime. It's about flexible rules processing. And ACS, all it does is claims in, claims out all the livelong day. And we have a very simple pattern. And I believe that simple pattern of claims in, claims out, being able to create these tokens, gives you the ability to build a lot of interesting applications, both on the web and in the enterprise. Make sense? So if you're going to walk away from this presentation with 3 things, I hope it's these 3. A couple things going forward. As John indicated with our timeline, we're in CTP phase right now. We're driving more and more towards V1, that's commercial availability. We will also have more information about pricing and SLAs and that kind of thing going forward as well. John indicated this summer of this year. I encourage you to go out and take a look at the different Azure CTPs that are out, right? So there's Azure, big announcements around that at MIX. I encourage you also to take a look at the .NET Services SDK as well. Go to azure.com for more information. I also encourage you to stick around and listen to my friend and colleague, Clemens Vasters, who will be talking with you about the service bus.
4:15.
Is it 4:15? Okay.
4:25.
Sorry. Don't come late. You won't want to miss a second, right? The service bus happens to use the access control service, by the way. So they're one of our customers, right? This simple pattern that we've been demonstrating here is exactly what the service bus uses to abstract away all the nuances of talking to different identity providers. Because the service bus is about connectivity, pub sub, and multicast kind of stuff. A lot of cool things to talk about there. They don't want to burden their code with knowing about lots of different identity providers. So the access control service is a way to abstract away a lot of that. Now, all the code that I showed, this token client, this authorization manager for the service host, is all going to be available on my code on my blog tonight. And in case you missed one of the 300 different identifying attributes about me, my blog address is right there, right? So blogs.msdn.com/Justin J. Smith. So we've still got some time left. I want to make sure 2 things are clear. One, I hope you fill out your evaluation form. Let us know what you think. If the session was good or not good, let us know. Fill it out either way. And I also want you guys to have a good rest of the conference. So that's it for me. I'm going to open it up for questions. If you feel like staying, feel free. If you feel like going, take off. Thanks. Questions?
How does this work with live IDs? Who uses live ID? Stuff like that?
So the question is, how does this work with Live ID? Does it work with PUIDs or the unique identifiers? You can fix this to work with Live ID just about however you want. So like if you've already got a relationship with Live ID, you've already gone through the setup, you can get different attributes depending on your trust level with Live ID about the end user. You can simply take those attributes, like a unique identifier that's unique to your site, and use that to drive access control rules. So you can do that. The portals themselves have a slightly different integration with Live ID. So the management portal that I showed you earlier, this thing, is actually using a slightly different interaction pattern for working with Live ID. Let me show you here. We use passive federation. So I can sign in to the portal, and I'm taken to Live ID, and here I can get into the portal, right? So we also have passive federation as an option for integrating with Live ID. Does that answer your question? Okay. Any other questions? Yes?
Is this only available as part of Azure, or is there any way we can set this up on our own server within our own environment without having to go out to the cloud?
So the question is there any way for me to set this up on my own servers without having to go out to the cloud? So right now, this rules engine and the mechanism that we're talking about for doing claims in, claims out is available in the cloud only. One of the common requests that we get from customers is, I want to be able to run this in my own cloud, whether it be Rackspace, Amazon, wherever it is, my on-premise, off-premise. I just want to be able to have the shrink wrap package, right? It's a very common request, and we're working on it. Our strategy is to view that as something that comes after we get the entire environment stabilized, running as we want before we shrink wrap it. Because if we have it out in the cloud and we go through the other engineering exercise of shrink wrapping something so that it can be installed and run separately, we can end up in a situation where it's, we're doing too many things at once. But the request that you made is a very, very, very common one. It's made across all of the services teams in Microsoft that I know of. Any other questions? Yes?
We're using certificates that were not first time any others. Is there any problem with that?
So the question is, I'm using certificates in this case that are not issued by a trusted certificate authority. All of these certificates are created using MIX09. So there's a couple of different ways that you can look at that, because the next part of the question is that a problem? Certificates can really do two things. One, they can serve as unique private and public key pair objects. They can also have some trust associated with them about the subject of the certificate and who it's issued to. And that's what we rely on VeriSign and other certificate authorities for. In this case, we're not using this certificate for SSL and for verification through a browser, right? So if I go log on to my bank, I don't want to see some untrusted cert, the big red, like, you shouldn't trust this cert, right? That needs to be a CA-issued cert. What we're doing in these examples is doing message level security. So the app just has to know about the certificate, right? And so you can trust that certificate as long as you've got other means for verifying where it came from. And so it's not really a problem in the way that we're using it. However, I could envision a scenario where a big company, like let's say Toyota, or let's say Microsoft internally, we start to do this. Those certificates that we use are going to be issued by trusted certificate authorities. But from a security perspective, it's not, it's 6 and 1 half dozen the other. Good question. Yes? What's the price for using a service? Another good question. We're trying to figure that out. This summer, we'll have announcements around that, right? So price is one question that comes up quite a bit. Another one is SLA, right? So what's the expected response time of this service? And what happens when we go outside of that expected response time? Like what's the compensatory action for that? How do you actually know that you're within your SLA or you're on the edge of your SLA, those kinds of things. This summer, we'll have announcements there. You can look at this in a few different ways. There are computing services that are out in the world today, right? So there's Amazon, there's Google, there's several others. Lots of companies are coming up with these. The precedent for the pricing points is almost expected by the market, right? Now, for raw compute and other sort of capabilities, that may be true. When you look at the access control service and you look at the service bus, they're different animals, right? These are components, if you will, that developers can use. And so we're trying to put our head around how the pricing will work for those different types of services that aren't sort of core compute, core storage. Make sense? Yes, another question.
Which is the market, or which are the markets you target with that solution? Or business applications or websites that target consumers, or even, let's say, you target the block owner who wants to identify his domain or something?
Yep. Yep. So the question is, what's the target market that .NET Services All Up is addressing? Is it consumer-facing web? Is it enterprises? Is it some hybrid of the two, right? And so the answer is our sweet spot, we believe, is addressing software vendors. Addressing the needs of software vendors that are writing applications that will be consumable by enterprises, but there's also some element of the web in there. So you can envision a big crossover space between the web and the enterprise. I believe that when the web meets the enterprise, the web wins, right? If you look at these two things as very different. And so I believe that there's quite a bit of crossover there. That being said, this was based on the assumption that enterprises were a little bit reticent about moving into the cloud. That does not appear to be the case, right? So I think the way we're approaching this is let's come up with patterns, let's come up with services that make sense and patterns that don't limit us to just one audience and release it that way. Obviously, when it comes to administration, when it comes to integrating with different identity providers, there's work that you do based on your targeted market, your targeted vertical, right? But our general approach is to make sure our pattern is applicable broadly. Good question. Any other questions? Shy. Oh, you're not shy. Sorry.
On enterprise applications, one of the requirements is for security reasons is like rotating passwords. Like you mentioned your Microsoft password, you have to rotate it every so often.
Yeah.
Is there any way to set those type of requirements, or at least know that those type of requirements are being followed?
And so the question is, if you look at an emblematic enterprise, there's policy around rotation of passwords. That pattern, how do we apply that pattern to something that's running in the cloud? So what we're showing here, I believe that's a question. The pattern that we're showing here is heavily reliant on certificates. If you want to implement that kind of a model where you roll over certificates frequently, obviously the certificates will have a timeout window, right? So they'll have an expires date on them. And as you roll into new certificates, we're looking at protocols for how you indicate that the certificate is about to be rolled over to all the relying parties. In my view, this is not a completely solved problem. And it's one that we've got to solve eventually, right? Because this is going to come up. I want my certs to rotate in a period of time, and I don't want to have a downtime for my service. I just want them to work, right? So one thing you know is you're going to have two versions of the cert available at the same time, right? And how you indicate to all the relying parties that the cert's about to roll over or get the new version is still kind of an open question. It's a very good question, by the way. There is some way of doing this. There's a mechanism for doing this in enterprise identity providers. So when you look at the Geneva server, and we call this trust lifecycle management. So the Geneva server has a mechanism for changing the signing cert that it uses. And there's a protocol in the system that will indicate to the different trust parties that the cert's being changed, right? So there's a mechanism for doing this trust lifecycle management. The broad applicability of that is something that we're looking at. Yes?
I think to follow up
Yeah, so the question is, you can't enforce. It's like trying to boil the ocean if you tell Facebook that they've got to roll over their password that you're using every so often, or their keys that you're using to integrate with Facebook. Yeah.
Maybe you can, but
Yeah. Yeah. And so when you go into the broader identity providers, he's absolutely right. That isn't in the cards yet. Any other questions or comments? Yes. Yes, it is publicly available. So the question is, where can we try this? Is it publicly available? You can go to azure.com, azure.com, and you can get into .NET services. You do go through the Microsoft Connect site, right, which asks you for your email address, those kinds of things, right? But it's publicly available. We get requests, and we approve the request virtually immediately. So previously, it's taken a long time. So right after PDC, when we announced these things, we were ramping up our capacity, and we wanted to have more of a check-in place so that if X number of users showed up immediately, we wanted to make sure we were braced for that, right? And so now we feel like we're at the point where it's fine. Does all of this work in Azure right now? So with the release of Azure in full trust, right? So your app domain is now fully trusted. You can work with the code that we're showing here. So all the code that I showed in this presentation will run in Azure in the fully trusted version of Azure. Now, there's some service bus, and Clemens can talk to this in the future, or in his next talk, but there's some service bus capability that isn't quite yet ready for consumption in Azure because of the sockets, the approach that the service bus uses to sockets, right? But all this stuff will run there. Okay, great. Well, if you've got any other questions, I'll be here. Otherwise, thank you for your time, and have a great rest of the conference.